In this video, we'll find out together why Chris Bryant calls DHCP the network admin's best friend. Well, DNS and ARP, obviously very important, but our host is going to need some very important info before it can even put DNS and ARP to work. And one of those pieces of information, of course, is where's the DNS server? The host is not created knowing what address we're using for that on our network. That host also needs to know what its IP address is. It needs to know what its network mask is. It needs to know what its default gateway is. It needs to know all this stuff. And we have two options when it comes to getting that information to the host. We could visit each and every host on the network personally and configure all of this information manually, which is a bad idea. And I'm not just saying it because it's not really effective. You know what happens when you have to visit the desktops when end users are there for some kind of update. We've all been through that. While you're here, and 10 desktop visits that you thought would take 2 hours, end up taking up 8. Not bad-mouthing our end users, that's just human nature. So it's really not a good idea on a social scale or an effectiveness scale, a logical scale, if you will, to visit every host every time we need a host to get that information. And what we could do is use DHCP to allow the host to acquire their IP addresses dynamically. This is a wonderful idea, said the person who once had to administer a network that didn't run it. Because DHCP is not just for that initial dynamic IP address assignment. Sooner or later, an important piece of all the information that DHCP gives our host, it's going to change. Things change. And in this case, the thing that's changing is the IP address of our DNS server. We're changing it from 192.168.1.1 to 192.168.1.100. Well, we would have two options to get that piece of information out. And if we're using static configurations, we get to go back to every single host and change one setting and add a DNS server. And then maybe you bring that server online and then you got to go back and take the other one out because your boss told you had to. Not that I'm speaking from personal experience, but I still have forgotten his name. Now with DHCP, of course, we get to let the hosts know about this change dynamically. The hosts are going to update the information themselves, and life is beautiful. And in today's networks, you've got to have this dynamic assignment and you've got to have this dynamic update potential, and that's what DHCP brings to the table. That's why it's so popular. There are 4 DHCP message types used in an address acquisition. And I'm going to give you an acronym for this, which you could probably figure out on your own, Dora. Yes. And first time around, if you need to use that acronym to remember them, no shame in that game at all. But after a while, it becomes second nature. The challenge here is that, like DNS, like ARP, DHCP works so well that we don't run into many problems with it until we get in complex situations, which we're not going to do here. But you don't really think about, oh, here's what's going on when a host gets an address. But for our exams, it is an excellent idea to do so, and that's what we're going to do right now. A quick style note here as well. A lot of DHCP documentation, it uses all uppercase to describe the packets we're about to see, and it'll cram them together in one god-awful word like DHCP discover, DHCP offer, etc. That really burns the eyes after a while. If you've ever read a Cisco doc on DHCP, you know what I'm talking about because you'll see that like 80 to 100 times in a couple of pages. I am writing them in a friendlier style, a little bit of lowercase, and writing it as 2 words. But when I say DHCP discover packet, I am talking about the same one Cisco is talking about when they use all uppercase and one horrible, ugly word. Now, our host is going to get that ball rolling by sending a DHCP discover packet, and this is a layer 3 broadcast. It's yelling to everybody, is anybody out there a DHCP server? We need to have a conversation. That's all the discover is about. Each and every DHCP server that receives that message is going to respond with an offer. And first, it's going to offer an IP address as part of this from that server's IP address pool. Our DHCP servers are going to have pools of addresses, and then one of those addresses is taken from the pool and put in this offer. And it can't be given to anybody else while this negotiation is still going on. Now, the network mask offered to the client is in there. The amount of time the client can keep and use that address, that's the lease, is in there. And the IP address of the DHCP server that's making that offer. All of that information is in that offer. Now, in a lot of networks, this particular host with the discover message is only going to be able to reach one DHCP server. But on other networks, that's not the case. You may have redundancy and you may keep them both online all the time. And you could have a wonderful situation like this, because we'll take all the redundancy we can get. And if we have two DHCP servers that can actually answer that initial message, they will both send back DHCP offers. And you can see they're coming from two different servers, and the host now has to choose which offer it's going to accept. And you may think in this world of logic and Cisco networking and etc. that it is an extremely complex operation, an algorithm, if you will, that the host will use to choose which offer it's going to take. You'd be wrong on that, because what happens is the highly scientific method involved is that the host will accept the first offer it gets. It's easy. It'll just take the very first offer that it gets, and then that's it. But then the host is going to broadcast another packet. This is called a DHCP request. And it sounds like, okay, what are you requesting? Well, the offer that the host just received, it has important information, but it's not going to have everything that the host needs to get started. And also, by broadcasting this DHCP request, this particular packet type identifies the server whose offer has been accepted. So the server that made the offer is going to see this broadcast packet and say, oh, okay, I need to send you some more information, and I'll go ahead and reserve this IP address for you. And the other server is going to say, oh, okay, he picked another DHCP server as the one. I've been rejected, so I will now return that IP address to the pool, and I'm free to give it to someone else. So the DHCP request, that's all it's about, is letting all the servers that made offers know, hey, here's the one I took, and if I didn't take yours, go ahead and throw that address back in the pool. We're moving forward. Finally, we wrap up with a DHCP ACK. And this is the end of the process. This is a little bit more information that the host is going to need, and then it's all over. So DORA with that ACK, and ACK ending the acronym, that is, and that's all there is to it. Now, you can configure a Cisco router to serve as a DHCP server. It's a good backup. It's a good skill to have, and a lot of people don't have it. And you can also have a Cisco router or switch on an SVI acquire its IP address via DHCP. Now, you may think that's not something we do terribly often, and you'd be right, because we usually want those addresses to be stable. We don't want to be pulling a random address out of the pool and putting it on a fast Ethernet interface. But that skill comes in handy once in a great while too. What I'm going to do, I want you to see some routing and get used to routing in action before we get to that. So I'm going to save that part of DHCP for later in the course. We'll definitely come back to it. And again, I'll show you exactly how to configure a Cisco router as a DHCP server and have a router get an address from a DHCP server. But coming up next, we are going to get started with a huge static routing lab. You definitely want to get something to write with before we start this, because there's a lot more information than past labs have had, and that is coming up next.